Hi everyone, in this video lecture we will solve one more example of maxima and minima of function of two variables. So here we have a question to discuss maxima and minima of function f, which is equal to x cube plus y cube minus 3axy. So I have already explained you the steps. So first what to do is we have to find out some partial order derivatives, and they are p, which is equal to del f by del x, n cube, which is equal to del f by del y, r, which is del square f upon del x square, it is second order derivative, s, which is del square f upon del x del y, and t, which is equal to del square f upon del y square. Alright, so let's calculate. So if we differentiate partially with respect to x, it would be 3x square minus 3ay. Del f by del y will be 3y square minus 3ax. Second order derivative del f by del x, when differentiated with respect to x, again it will be 6x del square f upon del x del y. If del f by del y is differentiated with respect to x, it will be minus 3a. Alright, and one more derivative is del square f upon del y square. Means if we differentiate del f by del y again with respect to y, it will be 6y. Now the first step to find maxima and minima is to put first order derivative p and q equal to 0. So start with p is equal to 0. P means 3x square minus 3ay. So we put 3x square minus 3ay is equal to 0. That gives us x square is equal to ay. So take it as equation number 4. Now we take second equation, that is q is equal to 0. So what is q? 3y square minus 3ax is equal to 0. That means y square is equal to ax. So squaring this, we have y to the power 4 is equal to a square x square. From equation first, as we can see, the value of x square is ay. So put over here, it will be y to the power 4 is equal to a square into ay. That means y to the power 4 is equal to a cube y. So it will be y to the power 4 minus a cube y is equal to 0. If we take y as common, it will be y cube minus a cube is equal to 0. So we have y is equal to 0 and y is equal to a. Now since we have y square is equal to ax, so x will be y square by a. When y is 0, the value of x will be a 0, which gives us 0 0, which would be a trivial solution. And next value, when y is equal to a, x will be a square by a, that is a. So we have next solution is aa. So we have two solutions, and that are 0 0 and aa. Now we check values of rt minus s square and r to discuss its maxima and minima. So now first we take point AA. Alright. At AA, the value of RT minus S square. So what is R? R was 6x and T was 6y. So it will be 36 xy RT minus S square. So minus S. S is minus 3A whole square. At point AA, it will be 36A square minus 9A square. So it will be 27A square. Since we know squares are always positive, so it is greater than 0. So at AA, we have RT minus S square is greater than 0. So we have maxima or minima. We can discuss maxima or minima at this point easily. So next we check value of R. Since R is equal to 6x at AA, it will be 6A. So it is positive or negative or it is 0. It depends on the value of A. So the question has been divided into 3 cases, and the case 1 is when A is greater than 0, then R will be 6A, so it is also greater than 0. So we have a case that RT minus S square is greater than 0 and R is also greater than 0. This case is of minima. So AA is a minima and function is having minimum value at this point. So we can calculate F minimum at AA, where A is greater than 0. So the function was, I remember, x cube plus y cube minus 3axy, and its minimum value will be at x is equal to A, y is equal to A. That is A cube plus A cube minus 3A cube, which is equal to minus of A cube. Alright. And we have second case, and that is when A is less than 0. So let's see second case. When A is less than 0, then R, which is equal to 6A, is also less than 0, and RT minus S square is 27A square. Though A is negative, the value of 27A square is greater than 0. So we have the case that RT minus S square is greater than 0 and R is less than 0, which is a maxima. So point AA is maxima at when A is less than 0. So we can find maximum value whenever the value of A is less than 0, and the function was x cube plus y cube minus 3axy, at which point AA, it gives us maximum value. So it will be A cube plus A cube minus 3A cube, which is equal to minus A cube. So this is the case when A is less than 0. And we have another case when A is equal to 0. So let's check the third case. At A is equal to 0. Since RT minus S square was 27A square. At A is equal to 0, the value of RT minus S square vanishes. It is equal to 0. That means we have further investigation. Further investigation is needed. And we have one more solution, if you remember, and that point was 0, 0. So at 0, 0, RT minus S square, whose value was 36xy minus 3a whole square, which is 0 minus 9a square, which is minus 9a square, and it will be a negative value. So at this point RT minus S square is less than 0. So we have neither maxima nor minima. At which point? At 0, 0. So in this video lecture we have solved an example and we have discussed maxima and minima of a function which is a function of two variables. Thank you.